Good morning, my dear students. How are you? Hope you all are very fine and safe. Here I am to take your Chemistry 1 class. We are talking about different types of enthalpy changes. Already in previous classes, we had discussed about enthalpy of formation, enthalpy of combustion, and enthalpy of neutralization. Look, dear students, all these enthalpy changes are occurred for the chemical change or chemical reaction. But today we are going to discuss the enthalpy changes of some processes where no chemical changes or reactions are happened. Rather, only physical changes are noticed in these processes. But here also, due to these physical changes, enthalpy or heat change is observed in these processes. Some of these processes are vaporization, fusion or melting, sublimation, condensation, dissolution, atomization, etc. Look, all these processes are physical processes because here no chemical reaction or chemical changes are seen. But here only the state of matter or condition of matter is changed. Now, our today's topic is enthalpy change of some physical processes. Now, some physical processes where enthalpy changes are noticed are enthalpy of fusion, enthalpy of vaporization, enthalpy of sublimation, enthalpy of condensation, enthalpy of solution, enthalpy of atomization, etc. Today, in this class, we will discuss all these enthalpy changes. At first, enthalpy of fusion. To know about enthalpy of fusion, at first you have to get clear idea about fusion. I know all you know about fusion. What is fusion or melting? Fusion is a process where solid matter melts and it is converted to liquid. Now, how solid matter melts? Do you know? A solid matter melts from solid to liquid, but how? A solid matter absorbs heat energy to melt from solid to liquid, to convert from solid to liquid. This heat energy, this is enthalpy of fusion. So, what is heat of fusion or enthalpy of fusion? Look here. The amount of heat needed to melt 1 mole of solid substance to its liquid state is called its enthalpy or heat of melting or heat of fusion. The amount of heat that is absorbed by 1 mole of a substance, that is called heat of fusion of that substance. Heat of fusion is denoted by del A is not fusion. Look, here solid water, that means ice, it is in solid form and it absorbs 6 kilojoule heat energy to melt, and after absorbing 6 kilojoule heat energy, solid water becomes liquid. So, heat of fusion of water is 6 kilojoule per mole. Sodium chloride, after absorbing 24 kilojoule heat energy, 1 mole sodium chloride is converted from solid to liquid. That means the heat of fusion of sodium chloride is 24 kilojoule per mole. Magnesium chloride, after absorbing 43 kilojoule heat energy, magnesium chloride melts to liquid. So, heat of fusion of magnesium chloride is 43 kilojoule per mole. Now look, dear students, in all these processes, these matters, solid matters, they absorb some heat energy. And after absorbing the heat energy, they are converted from solid to liquid. We know absorbing heat energy, this process is endothermic process. That means fusion is an endothermic process, and the heat of fusion or enthalpy of fusion is always positive. Del H is always positive here. Now, enthalpy of vaporization. You know what is vaporization? Vaporization is a process where liquid matter converts from liquid to gas. So, what is enthalpy of vaporization? How liquid matter is converted from liquid to gas? By absorbing some amount of heat energy. This heat energy that is absorbed by a liquid matter is called enthalpy of vaporization. But here also there is a condition that 1 mole liquid matter absorbs this amount of energy. So what is enthalpy of vaporization? The amount of heat needed to vaporize 1 mole of a liquid substance at its boiling point is called its enthalpy or heat of vaporization. It is denoted by del H naught vaporization. Here look, liquid water, it absorbs 44 kilojoule heat energy and is converted to gaseous water or steam. So heat of vaporization of water is 44 kilojoule per mole. Benzene, after absorbing 31.37 kilojoule heat energy, liquid benzene is converted from liquid to gas. So heat of vaporization of benzene is 31.37 kilojoule per mole. Like enthalpy of fusion, enthalpy of vaporization is also positive because in vaporization process, heat energy is absorbed by the matter, so it is also an endothermic process. And the value of del H is positive here. Now, enthalpy of sublimation. Sublimation, you know, this is a process where a solid matter is converted to gas without being liquid. It is converted from solid to gas directly. In sublimation process, also some amount of heat energy is absorbed by the solid matter, and after absorbing the heat energy, the solid matter converts from solid to gas, and this heat energy is called enthalpy of sublimation. Here also 1 mole solid matter is converted from solid to gas by absorbing heat energy. So, the change in enthalpy when 1 mole of a solid substance becomes vapor directly below at its melting point on heating is called its enthalpy or heat of sublimation. It is denoted by del H naught sublimation. Here iodine, it is solid iodine, it absorbs 62 kilojoule heat energy and it is converted to gaseous iodine. So heat of sublimation of iodine is 62 kilojoule per mole. Here look, like heat of fusion and heat of vaporization, heat of sublimation is also positive. Del H is positive here because sublimation process is an endothermic process. Here also heat energy is absorbed by the solid matter to make it gas. Now our next topic is enthalpy of condensation. All you know what is condensation. Condensation is the opposite process of vaporization. Here vapor is condensed to liquid. In vaporization process, liquid is converted to vapor, and in condensation process, vapor is condensed to liquid. Here in vaporization process, liquid absorbs heat energy to convert into gaseous, but in condensation process, a gaseous matter it releases some amount of heat energy to convert into liquid. Here, the heat energy that it releases is called enthalpy of condensation. Here, in condensation process, the gaseous matter releases some heat energy. That means condensation is an exothermic process. Here heat energy is released. So it is an exothermic process. What is enthalpy of condensation? The change in enthalpy when 1 mole of vapor of a substance is condensed to its liquid is called its enthalpy or heat of condensation. It is denoted by del-H not condensation. Look, the amount of heat that is needed to convert a liquid to gas is equal to the amount of heat that is absorbed by the gas to condense into liquid. For example, here gaseous water, it releases 44 kilojoule heat energy to convert into liquid water. That means here minus 44 kilojoule per mole is the heat of condensation of water. When liquid water is converted to gaseous water, then 44 kilojoule heat energy is absorbed by the liquid water. And here gaseous water releases 44 kilojoule heat energy and it is converted to liquid. So we can tell the amount of heat of vaporization and the amount of heat of condensation is equal, but their sign is opposite, because enthalpy of condensation, this is a negative value. Why? Because condensation is an exothermic process. Here heat energy is released, but enthalpy of vaporization, it is a positive value, because here heat energy is absorbed by the liquid to make it gaseous. So heat of condensation and heat of vaporization, they are totally opposite to one another, because heat of condensation, it is an exothermic process, and heat of vaporization or condensation is an exothermic process, and vaporization is an endothermic process. And heat of condensation and heat of vaporization, their value is same, but one is negative and another is positive. Now our next topic, enthalpy of atomization. Now dear students, look, most of the elements in our nature are monoatomic, but some elements like oxygen, hydrogen, nitrogen, chlorine, they are diatomic. Phosphorus molecule has 4 atoms in one molecule, and sulfur, it has 6 atoms. Now we will talk about diatomic molecule. When these diatomic molecule, oxygen, hydrogen, nitrogen, they take part in any reaction, then at first they are broken to its atoms. So to break a molecule from its molecular condition to atomic condition, some amount of heat energy is absorbed. This heat energy is called enthalpy of atomization. So what is enthalpy of atomization? The amount of heat absorbed by a molecule to convert from its gaseous molecule to its 1 mole of gaseous atom is called its enthalpy or heat of atomization. It is denoted by del-H not atomization. Now look, here 1 mole hydrogen atom, it is formed by breaking half mole hydrogen molecule. So 1 mole hydrogen atom is formed from hydrogen molecule. Here 218 kilojoule heat energy is absorbed. So heat of atomization of hydrogen is 218 kilojoule per mole. In the same way, 1 mole chlorine atom is produced from chlorine molecule by absorbing 121 kilojoule heat energy. So heat of atomization of chlorine is 121 kilojoule per mole. And heat of atomization of oxygen is 249.2 kilojoule per mole, because oxygen atom is formed from oxygen molecule by breaking, and when it is broken, then 249.2 kilojoule heat energy is absorbed. Now, dear students, look here. The heat of atomization is a positive value. Why? Because you know that breaking bond is an endothermic process, and here the bond is broken. Here hydrogen-hydrogen bond, chlorine-chlorine bond, oxygen-oxygen double bond. These are broken to make hydrogen atom, chlorine atom, oxygen atom. So to make one atom of these gaseous element, the molecule is to be broken, and to break this bond, some amount of heat energy is given. So these processes are endothermic process, and heat of atomization is always positive value. Now here one thing to be remembered, that per mole of atom is to be formed, not from per mole of molecule. You have to remember this thing, that to make 1 mole of atom, the heat energy that is absorbed is called enthalpy of atomization. Now, our last topic, that is enthalpy of solution. You know that when lime is added into water, then heat is evolved. You know about this. And again, when glucose or potassium nitrate is dissolved into water, then what happened? The water becomes cold, because here heat energy is absorbed. So in some process heat energy is evolved, and in some process heat energy is absorbed. But all these processes are dissolution process. Here all these are dissolution process, and the heat energy that is absorbed or the heat energy that is released, they are called enthalpy of solution. So what is enthalpy of solution? The change in enthalpy of the system when 1 mole of solute, look here, 1 mole of solute is dissolved into sufficient amount of solvent. The amount of solvent is not fixed, but the amount should be sufficient, so that further dilution of that solution produces no more change of enthalpy. It is denoted by del is not solution. So what is heat of solution? When 1 mole of solute is dissolved into sufficient amount of solvent, then the change in enthalpy of the system is called heat of solution. It is denoted by del is not solution. Now, generally 200 to 450 ml solvent is sufficient for 1 mole of solute for this purpose. 1 mole of solute, if you take, then 200 to 450 ml solvent is sufficient for this process. Now, usually heat of solution is an endothermic process. But if any reaction occurs between the solute and solvent, then the heat of solution becomes an exothermic process. The dissolution process is an exothermic process, and heat of solution is negative then. Look, the first example that I have told, when lime is added into water, then heat energy is produced. Why? Because lime, that is calcium oxide, when it is added into water, then it reacts with water and it makes calcium hydroxide. That means here the solute calcium oxide and solvent water, they react with each other. So here heat energy is produced. In this way, if in dissolution process any reaction occurs between solute and solvent, then the dissolution process becomes an exothermic process and the heat energy is produced in these processes. But if no reaction occurs, then the dissolution process will be an endothermic process and heat energy is absorbed in these processes. But if the reaction occurs, then heat energy is released or evolved. Now look here, copper sulfate. It is anhydrous copper sulfate. When anhydrous copper sulfate is added into water, then at first 1 mole copper sulfate, it reacts with 5 mole water and it makes hydrated copper sulfate. That means blue vitriol. And when this dissolution process occurs, then minus 66.04 kilojoule heat energy is produced. Why? Because here the copper sulfate and water, they react with each other and they make hydrated copper sulfate. Now here this is a hydration reaction because here the molecule is associated with water. So here reaction occurs, chemical reaction occurs. So the dissolution process will be an exothermic process. In the same way, when calcium chloride is added into water, then at first 1 mole calcium chloride, it is added with 6 mole water and it make hydrated calcium chloride. So in this process, minus 75 kilojoule per mole is the heat of solution. That means 75 kilojoule heat energy is produced in this process. In these two dissolution processes, chemical reaction occurs between solute and solvent, and these are hydration reactions. So here heat energy is evolved and del H becomes negative. But when this hydrated calcium chloride is given into water, then it is hydrated, there is present 6 mole water, no new reaction occurs here. Calcium chloride, hydrated calcium chloride, it is dissolved into water. It is also a dissolution process, but here the heat of solution is 19.06 kilojoule per mole. That means here 19.06 kilojoule heat energy is absorbed in this process. Here no chemical reaction occurs, so here heat energy is absorbed and del H becomes positive. In this way, if this blue vitriol is added into water, then no new reaction occurs and it will be a dissolution process, and this dissolution process will be an endothermic process. Here heat energy is absorbed in this process. So my dear students, today we had discussed some enthalpy changes, and all these processes are physical process. So today up to this, goodbye everyone. Thanks to all.